complete 5-5, we're going to do just a little bit of practice. So our normal homework assignment would have been page 554, 4 through 60, multiples of 4. I'll do every other one of those and then have the answers posted for you to take a look. Number 4 should have been a part of yesterday's notes, the amplitude, that 1/4 in front. It's just a fourth of the height. So it still goes from 0 to 2 pi, but the max would be at pi over 2 and 1/4 instead of 1. And then at 3 pi over 2, it would be at negative 1/4 instead of negative 1. So jumping to number 8, to determine the amplitude. So for number 8, because there is no coefficient out in front, the amplitude just stays at 1. So it'll have that height of 1. And then the period, remember, is 2 pi divided by b, so divided by 4. So the period now is actually pi over 2. So in terms of what that means graphically, if my amplitude is staying the same, then I go from 1 to negative 1. And if I remember, sine starts at 0, it peaks, it crosses, it dips, and then it finishes again. This is telling me then that it's going to be finishing at pi over 2. So my period is how long it takes to see that one full cycle, if we think of it that way, which means the center halfway then would be at pi over 4. And so these very rough sketches, if you want to backtrack like that just to work into what's happening, that's absolutely fine, just to get an idea of what it looks like. And we can always refer to the calculator for a cleaner picture if needed. So 12 will leave, 16 we can try. So 16, my amplitude again stays at 1 because there's nothing there in front. This one did flip on me though. My period, if I'm going to take 2 pi and divide it by 4/3, that's the same thing as taking 2 pi and multiplying it by 3 over 4, which if I multiply, that would be 6 pi over 4, which is the same thing as 3 pi over 2. And so this one again, if I think of my graph, at 1 and negative 1, since that amplitude stayed at 1. The issue is that I have to go down and then up and then up and then down to finish this one off because of the negative that's in front. So that causes that flip that we see. So this finishes at 3 pi over 2, which if we had actually left that as 6 pi over 4, then half of that we would have seen was 3 pi over 4, just to see where that's crossing. Not absolutely necessary, but it's there to take a look at what happened. So 16, leave 20. Let's take a look at 24. So now we have a different set of directions here because not only do we have the amplitude and the period, but we're looking at a phase shift. So for 24, I actually have an amplitude of 1/2. So it's half the height that it was. My period, though, is just 2 pi. It would be over 1 because of the x that's there. So nothing changes. My phase shift, we'll actually write out phase, was b divided by, c divided by b. And so C for this one, sorry about that. A is the 1/2, B is the 1, and C is the pi. And so it is going to be simply pi over 1. But again, because that's a plus and this was written in terms of minus, we actually have to think of that as like a minus a negative pi. And so the phase is actually negative pi to see how that one shifts. Okay, so this phase shift is something that we haven't seen before. So this, again, if it's shifting it left or right for my start, that means that I'm not starting at the origin like what I'm used to. I do have my 1, but then I have a 1/2 where it's really going to see the max and min, and then down to -1. So I'm going to need to address that shift. Let's take a look at the calculator just to be as neat as we can be. So 1/2 times the sine of x plus pi. And then if I go to my window, I'll go back pi units, and then we'll go out to 2 pi because we're used to it being 0 to 2 pi, and it can count off by pi. That's fine. I don't need to be all the way at -3 and 3 anymore. And so you can see instead of starting at the origin, it started left at pi. So it actually finishes at positive pi, and then it's another half period to get to the 2 pi. And so if I start back here at -pi up to positive pi, a height of 1/2, oh my, a height of 1/2, and then crossing through at the origin this time, and then finishing back at pi. We were only asked to do 1 period of it, so we could continue on and on and on and on, but we can also just stop right there. So 28 you can try, and now we're jumping to cosine. So this is just same directions, baby steps again, the amplitude for each one. So for 32, my amplitude would be 3. So for my cosine function, -3 would be my minimum, and +3 would be my maximum. And if I think of pi over 2 pi, 3 pi over 2, and 2 pi, I'm just counting off by pi's instead. This one starts at that maximum at 0 degrees, 0 radians. And so it would be crossing and finding its minimum at pi, and crossing, and then back to its max at 2 pi. So again, it's very similar to the sine function. It's just been shifted. So this one thinking in terms of that U shape instead. So 36, the amplitude is just 1, but that period has changed. And then 40 has a couple of things going on. So 40 is going to flip because of that negative, but still my amplitude is 3. And then my period, 2 pi divided by 1/3 is like 2 pi times 3. So I actually have to go 6 pi in order to see my cosine function in its entirety. So it's been spread out that far. So if I go to 3 and -3 again, so halfway would be 3 pi. And then to finish it, I'd be out to 6 pi. I'm now starting at -3, crossing, peaking at 3 pi, crossing, and then finishing at 6 pi. Because again, this looks like a little bell curve. I had that negative in front, which caused it to reflect over. And you could, again, check in the calculator to see what's where, but kind of bare minimums, just labeling those important parts to see what happened to the amplitude and period there. So skipping 44, we'll take a look at 48. So this has a little bit of everything happening here finally. So for 48, A is 1/2, so that's my amplitude. B is the 2 that's in front of the X. So my period is 2 pi over 2, which is just pi when that simplifies. And then my phase shift that I have to deal with is C over B. And again, this is like the last one because we're shifting, and this is old news. We're shifting to the left whenever it's a plus because it should be in the form of bx minus c. And so that sign's opposite from what we think. So negative pi divided by 2, because again, the phase shift is simply B over C. And so that's how far left I actually have to start. So let's see how this one looks. So I only have a height of 1/2 and negative 1/2. Come here. And I'm starting back at negative pi over 2. And it only takes pi to see the entire thing. Let's start that all over again. So my negative pi over 2 that I have to shift to positive pi over 2, that's actually 1 pi. And so I'm going to really just split this over the vertical axis there. And so I'm starting at my maximum height at the beginning, which happens to be at pi over 2, crossing right in the middle, it reaches the min, crossing, and then it gets back up to maximum height again. And so as nicely as you can draw that on paper, I'm working on doing it on my screen, and it continues in either direction. And again, can be checked on the calculator in order to see that that is in fact where it should be. 52 has all sorts of stuff going on, and then 56 and 60 would be the last two. Let's take a look at 60 because there's so much going on. So the vertical shift we haven't talked a whole lot about. So it's got an amplitude of 3, and then it flips because that's actually a negative 3. The sign of 2 pi x means that my period 2 pi divided by b is 2 pi over 2 pi, which is just 1. And then that plus 2 we haven't talked about, but it goes vertically up 2 units. And so what we see here that we haven't had to really work with before is where that center line then becomes. So that's what my up 2 will do. So think of this like your new axis in terms of where things peak and intersect. And so it actually, with an amplitude of 3, would end up at a height of 5. And then if I go down 1, 2, 3, the min is at negative 1. And so since this only has a period of 1, I'm just going to think again about breaking that up halfway and then finishing at 1. So because this flipped over, I'm going to start at what would have been my 0, 0. It's now 0, 2 because of that change. And then I am going to go down first to my minimum and then intersect. And then I'm going to go up to my maximum, which would be at like 3/4, 5, and then come back down to finish. That's a really challenging one, putting all of those pieces together. And again, it's recognizing how similar these transformations are to the other transformations we've done with algebraic functions, and being able to, if you can figure out what the period is, what the window should be a little bit to get at least an idea of where it should be, you can always just put these in the calculator to check and see what happens.